The question says for principal quantum number n is equal to 4, the total number of orbitals having L is equal to 3. Okay, we have to calculate the total number of orbitals when AG modal quantum number value L value is 3. Okay, so to determine the number of orbitals we use magnetic quantum number value. Okay, magnetic quantum number, because magnetic quantum number represents the number of orbitals. Okay, L value is given there, and by using L value we can determine the number of orbitals. We have the formula: magnetic quantum number ML is equal to minus L, then we have 0, and then we have plus L is there. Okay, we have to take minimum value of L and we have go up to the maximum value of L including 0. L value is 3, so we can mention this is your minus 3, minus 2, minus 1, 0, plus 1, plus 2, and this is what we have plus 3 there. Minimum value of L minus 3, maximum value of L is what? Plus 3 is there. And in between whatever the digits are coming, we include those one including 0 also. How many total values are there? 1, 2, 3, 4, 5, 6, 7. 7 orbitals are there. 7 orbitals. If you want to determine subcell, what type of subcell? L value is there. You keep in mind L value is 0 for S subcell, 1 for P subcell, 2 for D subcell, and 3 for F subcell. So subcell is what? F. Subcell F, in which how many orbitals are there? Total 7 orbitals are there. That's why we use 7 boxes. Okay, there is also one more formula. We have ML is equal to 2L plus 1. Directly you can determine number of orbitals. You can see ML value is depending on L value. L value is 3 is there. We can plug in here 2 multiplied by 3 plus 1. We get 6 plus 1 is equal to 7 is there. So how many total number of orbitals? We got 7. We have 7. Okay, N value 4. L value 3, so we got orbital F is there, 4F. From here we determine the total number of orbitals. 4F is there. In F how many orbitals? 7 orbitals. How? You can see we have the detail. If you like this video, please share and subscribe to the channel.